let's go over some trigonometric identities. In the first row, we have what we call our basic identities. If we let's start by looking at the second row. The second row really is how we define the trig functions secant, cosecant, and cotangent. Secant is 1 over cosine, cosecant 1 over sine, and cotangent is 1 over tangent. Now, one way I like to remember these identities, or these definitions, is that a co goes with a function that's not a co. In other words, secant doesn't start with co, and it is defined as 1 over cosine. So you have something with a co corresponding to something without a co. And here, cosecant is equal to 1 over sine. There's a co. Sine is not a co. And cotangent is equal to 1 over tangent. So there's your co, cotangent, and tangent does not start with co. All right. Now let's look at this basic identity. Tangent is sine over cosine. All right. If we have, let's see where that comes from. Let's draw a little triangle, a right triangle. And let's say we put angle x over here. And let's make the hypotenuse equal to 1. Well, we know that sine x is equal to this side over this side, opposite over hypotenuse. That's equal to sine x. So that means that if this is 1, this side must be actually sine x itself. All right, because sine x is equal to this side over 1. So when this is 1, this is actually sine x. And if this is 1, cosine x, for the same reason, must be equal to the adjacent side, because cosine is this side over 1. So this side must be equal to cosine x in this particular triangle. So we see from this diagram, for this triangle, that tangent, which is opposite over adjacent, tangent x is equal to sine over cosine. All right? Opposite over adjacent, sine over cosine. So that's how we establish this formula. Now let's look at what we call the Pythagorean identities, because really they come from the Pythagorean theorem. If we continue to look at this triangle that we drew and apply the Pythagorean theorem says that this side squared plus this side squared is equal to the hypotenuse squared, or sine squared, basically sine squared plus cos squared is equal to 1 squared, which is 1. So that's where we get this identity. And let's look at the second one. These three are grouped together because the second two come from the first one. If we combine this identity with this top identity, we get these two. So let's say if we take the top identity and divide both sides by cosine squared. All right, so let's do that. Let's divide by cos squared over here. And sorry, this is an x here. Divide by cos squared and cos squared. Sine squared over cos squared, that's our tan squared. Cos squared over cos squared is 1. And 1 over cos squared is secant squared. So that's how we get our second identity. And this third identity we also get from sine squared plus cos squared equals 1, this time dividing both sides by sine squared. Okay, so right here we did that. We divided this Pythagorean identity with sine squared, and we see sine squared over sine squared, that's 1. Cos over sine is equal to cotangent. Tangent is sine over cosine, and cotangent is the reciprocal, so that would be cosine over sine. So here we have cotangent squared, and 1 over sine is cosecant, so here we have cosecant squared x. So that's how we establish the second identity. And here we have what we call the sum and difference identities, and we just have to memorize them. One thing you notice is that they all start with angle A and then B, then A and then B, in that order. And sine has sine, cos, cosine, alternating trig functions in each term. and the plus corresponds to a plus, and here we have a minus corresponding to a minus. Now with cosine, cosine is cos, cos, sine, sine, and here a plus corresponds to a minus, and a minus corresponds to a plus, the opposite of sine. So these are the sum and difference formulas. And now if we look at the double angle formulas, well, the double angle formulas come from the sum and difference formulas. All right, so let's say sine 2a comes from this formula by replacing b with a. So if we just put an a over here, we have a plus a, which would be, that's our 2a. And what we're doing is we're replacing each b with an a. So here we have two terms which are the same, sine a, cos a. And here we also have sine a, cos a. So that's 2 sine a, cos a. So that's where this one comes from. Now, cos 2a comes from this formula, also replacing b with an a. So the same way we did above, just replace the b with an a. And here we have a plus a, that's our 2a. And here we have cos a, that's our cos squared a. And here we have sine a, that's our sine squared a. So that's where this formula comes from. Now what about these two? Well, I grouped these together because these two come from this one. So if we take this formula and if we replace sine squared by 1 minus cos squared, then we have cos squared, opening parentheses, we have cos squared minus 1 plus cos squared. So that would be 2 cos squared minus 1. So that's how we get this formula. Okay, now if we take cos squared and replace it with 1 minus sine squared, we have 1 minus sine squared minus sine squared. That's 1 minus 2 sine squared. So that's how we get that formula. And finally, let's look at the two identities for cos squared and sine squared. Well, they come from these two. So starting with cos squared, if we look at this identity and solve for cos squared, that is, add 1 to both sides, so we'd get cos 2a plus 1, that's this, and then divide by 2. So you see, that's how we get this identity. All right, and now this one, this identity, sine squared, if we comes from this identity, solve for sine squared. All right, and let's say we do that. We would put, let's say we put the 2 sine squared a on the left. Let me do that here. 2 sine squared a, I'm adding it to both sides, so that's going to go on the left side. So I have 2 sine squared a, and now I'm going to put the cos 2a on the right, so I'm going to subtract it. I still have this 1 on the right, and now subtract cos 2a. So I'm just moving this formula around. Now divide both sides by 2, and we get what we have over here. Sine squared a is equal to 1 minus cos 2a divided by 2. So that's how we get this formula. Okay, so those are all the trig identities that we've come across in this class.